In this video, we're gonna focus on converting a hexadecimal to decimal number. As I said it before that hexadecimal is a base of 16 and decimal number system is base of 10. But before we start, we need to know about the relationship between decimal number to hexadecimal number. So, 0 corresponds to 0 in the hexadecimal system, follows to 1 corresponds to 1, 2 corresponds to 2, 3 corresponds to 3, 4 corresponds to 4, and so forth all the way to 9. While 10 is corresponds to A, 11 is corresponds to B, 12 is corresponds to C, 13 is corresponds to D, 14 is corresponds to E, and 15 is corresponds to F. So, F is the highest digit in the hexadecimal system. Notice that the highest number that we see here is 15. Now, the hexadecimal system is a base 16 system. And if you include 0, we have a total of 16 numbers. So just keep that in mind. Now, let's work on some examples. So based on our previous lesson, we were gonna convert 2B1 in the hexadecimal system back to its decimal system. So, how can we do that? First, the first number 1, we're going to multiply it by 16 to the power of 0. The second letter, B, we're going to multiply that by 16 to the first power. And then the next number 2, we're going to multiply that by 16 to the second power. So we have 2 times 16 to the power of 2 plus, now you need to convert B from a hexadecimal system to a decimal system. So based on this chart, B corresponds to 11. So this is going to be 11 times 16 to the power of 1 plus 1 times 16 to the power of 0. So let's do the math. 2 times 16 to the power of 2 is 256 plus 11 times 16 to the power of 1 is equals to 176 plus 1 times 16 to the power of 0 is 1. So 2 times 256 is equals to 512 plus 176 plus 177 is equals 176 plus 1 is equals to 177 is equals to 689. So, this is the answer in the base 10 system. So that's how we can convert a hexadecimal in the base 16 system to a decimal number in the base 10 system. So it's similar.